Welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. In this video, we are going to continue talking about the basics of the Scala language and programming in Scala. And in particular, we're going to talk about objects and methods. So Scala is what is known as an object-oriented programming language. And Chapter 1 talked a little bit about the different approaches to, or the different paradigms for programming. And one of those paradigms is object-oriented. Now, Scala is actually a multi-paradigm language. It combines several different paradigms inside of it. Object-oriented happens to be one of them, and in many ways, Scala is a rather pure object-oriented language in that every value inside of Scala is an object. So let's go ahead and let's start up Scala. And last time we saw that we can type in simple literals and get back values for them. We can also type in various expressions where we put things together. We saw that in addition, so there were two types of numbers: integers, which were only whole numbers, and double, which could allow fractional values as well. We saw that if we put characters inside of double quotes, we get something called a string. The string is made of characters, and you can create individual characters by putting them inside of single quotes. Note that you can't put two characters inside of the single quote because that is no longer a single char. And then at the end we talked about the Boolean, which can be true or false. So the question is, we've said that Scala is an object-oriented language. What exactly does that mean? What does it mean for a language to be object-oriented? And the basic answer to this is that an object is something that combines data and functionality. So an object knows certain things. It has information associated with it, and it also has functionality in the sense of things that it can do with that data. And when you stick those together, you basically have what programmers refer to as an object. And there are lots of different programming languages that do this in different ways. They make it so that you can construct objects in different ways and whatnot. But the fundamental idea is that you have an object and you can pass it around to different parts of a program. And when a part of a program gets that object knows things and knows how to work on its own. And prior to object orientation, you would have collections of data and you would have collections of functions, and they would be separate. And so you could pass the data around, but the data didn't inherently know how to work on itself. It didn't know what it was supposed to do. And objects have that in them. And this leads to the next thing. Well, how do we get hold of these things that objects can do? Okay, how do we call the stuff on them? And the functionality that's contained in an object we refer to as methods. And so in this video, I want to show you how we can call methods on objects. So the REPL here can actually give us a little assistance with this. The standard syntax in Scala for calling methods is the dot notation, and this isn't just Scala. This comes from a long history. You have Java used it, and even C, when there weren't methods as part of this, it was just how you group data. You use the dot notation to get data out. And so Scala continues with that. And so we can do something like tell the integer 5 to convert itself to a string. Okay. So remember, 5 is this int literal. Okay, it's an object, it's of type int, and it has the value 5. And what we're doing here is we're saying to call a method on 5, and the method that we're calling is toString, which converts the 5 to a string, and you can see what we get back. The result of that is basically an object that we could also get that way, okay, where the 5 inside of double quotes. Next question would be, how do you find out what methods there are on things? What can you call on 5? I just pulled out toString. There are also methods like toDouble, so that you can convert an integer to a double. If you have a double, there is a method for converting it to an int. The REPL can help you see what methods there are because it has tab completion in it. Now, I will point out that I have to do something a little bit interesting when I'm doing an int. So if you type in 5 point and you hit tab, that doesn't realize you want to call a method. It thinks that you're typing in a double, and it won't bring it up. But if I put the 5 in parentheses and then put a dot, the parentheses offset it and say, okay, so I'm not trying to get like 5.3. I want to call a method on that 5. And you can see here a list of methods that you can call on an int. We already looked at toString and toDouble. You can also convert them to characters. There are other types, bytes, longs, shorts. You can convert an int to an int, and there's a type called float. The methods that we saw last time for when we were doing addition, so when I did 5 plus 3, it turns out that the way Scala looks at this, that is actually a method invocation. What Scala sees is 5 plus 3. And as you see, I get the same result out of this. As a general rule in Scala, if you have a method that takes 1 argument or 0 arguments, you can leave off the dot and leave off the parentheses around the second argument. And we'll see more of that later, though at least to start off with, most of our methods we will call with the dot notation. But it's not absolutely required. So 5 space toDouble, it figures out, oh, you are calling the method toDouble on the 5. But most of the time, especially early on, I will leave in the dot to make it more explicit for you. You can also see there are some things in here that we haven't talked about, and those will be introduced later. So that shows you what you can do with an int. If I do this with a double, and I will have to put the parentheses in. Oh, that's interesting. It's not. Let's do 5.3 and then use the name that it gives to it, res16 dot, and hit tab. You can see very similar set of operations for the double. What about a char? Similar set of operations. Now, what happens if you convert a char to an int? You get a numeric value for it. So if little a is 97, you would expect little b to be 98. And little c to be 99. These values are encoded using what's called Unicode, and actually the lower part of that is typically referred to as ASCII. And so in a very fundamental way, everything that the computer does is work with numbers. And so even characters wind up being encoded as numbers inside of it. Even strings wind up being encoded as a bunch of numbers together. Now this can be helpful at times because you can say something like, well, what is, if I go 3 letters past A? Well, we saw last time that converts to an int, but now we know that we can convert that back to a character and get the letter D out of this. So this ability to use letters as numeric values and do math on them is something that we'll actually take advantage of a bit over the course of the book. What about strings? Here are a set of methods that you can call on a string, and we can, a simple one that doesn't take any arguments is length. So you can say hi.length, and of course hi has 2 characters in it, so its length is 2. Another method that doesn't take any arguments is empty. Well, high is not false. However, if I give it the empty string, that is empty. Some of these methods take additional arguments, and your book actually goes through and looks at a number of these methods that you might find helpful. So how about we'll take one of my favorite strings and do index of. Okay. Index of is a method that searches for something inside of it and tells you the first instance of it. So in this case, it's saying that the TE here is located at index 10. And you might start counting and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and you think, oh no, it's wrong. Turns out that for most things where you are dealing with indices, we will start counting at 0. So in that case, the capital T is at 0, and this is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so indeed the TE is at index 10 there. What about replace? So try that finds the first instance of something and replaces it with whatever it is that you tell it to do the replacement with. As you can see here, there's methods to convert it to lowercase, convert it to uppercase. Many of these methods are things that we won't use at this point, but we might start using them later on for doing things with strings when we start playing with text in a more significant way. So that shows you the basic syntax of how you call methods on things, and how through that how we can do conversions from different types by calling the methods that are things like toInt and toDouble and toChar. There's one other type that wasn't mentioned in the previous video that is worth describing because it is going to be useful to us, and it is a built-in type in Scala, and that is the type called a tuple. Now, a tuple is a standard math term, and it's a collection of multiple values, potentially of different types. So, points in 2-space are a tuple of a real and a real, is how you view them often in math. We can make tuples in Scala by putting a comma-separated list inside of parentheses. And perhaps the most interesting thing to note about this is the type. So 5, 8.5 is an int double, and if I add in the comma high, it's an int double string. This tuple just allows you to group things together where each thing preserves its type and it knows what type it is. If you have a tuple, how do you pull values out? Well, one way is actually to call methods on them, and that's part of why this fits in nicely here. So res28, which was this 5 and 8.5, has a method called ._1. By the way, the getting values out of tuples is one of the few places where we do start counting at 1. _1 is the first value, and _2 is the second value. And if we went to res29, which was this 3 tuple here, we would also have a 3, and we could get out the high. And so note that I can do, on that I can call the length, and then I get 2, because that is the length of the string high. So these tuples give you the ability to group things together and pull them out, and that winds up being helpful to us in a number of situations, especially when things kind of go together. For, as I mentioned earlier, a point in 2-space is represented very nicely as a tuple of double-double. If you had a student in their grade, you might have just a string and an int. We'll find out later there are other ways of grouping things as it gets bigger that have more meaning to them, but for small groupings of data, the tuples are really helpful for allowing us to do that early on with a simple syntax. It's worth noting there is one other syntax for producing two tuples, so this only produces tuples with two elements, and that is a right-pointing arrow. It's a minus and a greater than, and that can produce a two tuple. Now, as I said, it only produces a two tuple though, because if you put two of them in a row, you get a two tuple inside of a two tuple, okay, as opposed to getting a three tuple. So keep that in mind. We will wind up seeing this later, and there are definitely places where this is more readable than the syntax with parentheses and commas. And so it winds up just being a helpful shortcut in certain situations. So you should, at this point, bring up your REPL and start trying to type in some simple expressions. Start trying to call up some methods. You remember, you can use the tab completion to show you methods that are available. See what those methods do and play around with it for a while to see what happens. And that's it for this video.